this lesson, we're going to introduce all these sayings and topics in probability. You may have done this in previous years, you may have not. So just be aware of that. I'm just going to fly through them. But we're going to do some simple probabilities and then learn language of probability. There's probably a couple more language terms that will come up that are not in this video, but hopefully this gets you through the majority of it. So language of probability. So that's the title, learning goal. Let's go. All right, key words, chance experiment. What is the chance of rolling a 3 on a 6-sided die? Okay, so chance is just like, what are the chances? And in essence, that's what we're doing in probability. We're finding out chances of something. Trial is like, you can flip a coin once or you can flip it 10 times. So the trials could be, there was 10 trials. And if we're talking about flipping a coin, that means that we flipped a coin 10 times. Yeah. So there was 10 different trials. And outcome is just like the outcome. All right, when I put my hand in a jar, I got a red jelly bean. All right, so outcome is the event that happened. All right, so the finalization. I won't write anything down. So outcome is just write this down and you write little notes down. So outcome is what happened. And sample space is every possible outcome. So ties in with outcome. So sample space, if we're rolling a die, so rolling a die, the sample space will be 1, 2, 3, 4, 5, 6. Because those are all the possible outcomes that we can get when rolling a 6-sided die. We can get 1, 2, 3, 4, 5, 6. That's the sample space. So we go S and we put curly brackets. Sample space of a coin is heads, tails. If I was running a raffle in the class, the sample space would be everybody's name, because that is who could be the outcome, who could get the outcome from the raffle. So just be aware of that. So outcome is every possible, sample space is every possible outcome. Okay. Now down here I've got a line, and everything in probability happens between 0 and 1. In the middle we have half or 0.5, and we say that's even chance. At 1 we say it's certain. So for example, tomorrow the sun will rise, that's a probability of 1, it's certain. Impossible. So impossible is something that's impossible. So tomorrow is 2012. That's impossible because it's already happened. Okay? And over here, closer to the certain, we have likely. And here will be very likely. Down here we have unlikely. And then here we'll have very unlikely. Okay? So this is the probability chart. So you can't get anything in probability that's greater than 1. Okay? So everything is between 0 and 1. Okay? All right, let's do in an example. In the word sensational, it says count number of letters. So there's 2 parts in this question. So the number of letters, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So is it 11 letters? And find the probability of getting an S. Now, how many S's are there? It looks like there is 2. Okay, so the probability of getting an S, now make sure you write it like this. This means probability, and the event is getting an S, is going to be 2 out of how many letters did we count? 11. Okay, so 2 is the event, and 11 is total possible outcomes. Now let's look at the probability of getting an E. It looks like there's just one E, so that's going to be 1 out of how many letters is there? 11. Okay, so we write it like that. And the probability of not getting an E, so we're going to write E with a little hat on it. That means not. So let me highlight that. That means, I'll point to it, not. All right, so that means not E. So that's every other one. So it's going to be 10 over 11 because we've got to take the probability of getting an E out of the whole possibility. So not E is everything else other than E. All right, so that's the first example. Make sure you write it down. Second and final example. So we have a table here. So this table tells us the number 4 on A, and I've got to write more information. 6, probably not in blue. 6-sided die. All right, so we're just rolling a die like a Monopoly. And so what this tells us is how many times we get a 4. So we rolled it many times. 32 times we got no 4s, so we rolled a die. 7 times we got 1. 7 times we got 1 4. 6 times we got 2 4s, and 3 times. So we're rolling 3 die, okay? So because you can only get 4 dice, so 3 dies are cast. The number of 4 comes out. Find the total number the die was tossed, or the dice were tossed. Well, we've got to add all these up. 32 plus 7 plus 6 plus 5. So let's go 32 plus 7 plus 6 plus 5, and that equals 50. All right. Find the experimental probability of getting 2 4s. How many times did we get 2 4s? That's here. We got it 6 times. So probability of 2 4s is going to be 2. No. How many times did it occur? Oh, I don't know. It occurred 6 times out of possible 50 times, and we can reduce that, simplify it to 3 over 25. Okay, so that's part 2. And then part 3, find the experimental probability of getting fewer than 3 4s. Now, immediately we want to go to here, but it says fewer than 3 4s. So 2 is fewer than 3 4s, 1 is fewer than 3 4s, and 0 is fewer than 3 4s. So we have to add them all together. So 32 plus 7 plus 6, and that equals 45. So the experimental probability of getting fewer than 3 4s will be 45 out of 50, which we can simplify down to 9 over 10. All right, I hope that makes sense, but that's it from me. Peace out.